before we even talk about systems of inequalities, I'm going to talk about inequalities in two variables first. So linear or nonlinear. So we'll start with a linear. Let's say number 7 on 599. Y greater than 2x minus 1. So this is a linear inequality, but it has two variables. We have never seen this before. We've seen this before. 2x minus 1 greater than or equal to 0 is 2x greater than or equal to 1, or x is greater than or equal to 1/2. This is what we've been doing all along. But this is not the problem here. What we have here is an inequality with two variables. What do? I can't solve. The only way is step 1. Present the corresponding equation. I am not changing the inequality into an equation. I need to see the equation that corresponds to this. In number 2, graph y equals 2x minus 1. No problem. When x is 0, y is negative 1. When y is 0, x is 1/2. So 1/2 comma 0. I found the x and y intercepts like we always did in the past with lines. I'm going to plot those 2 points. 0, negative 1, and 1/2 0. At this point, I'm going to stop. I will not connect the points before I look at this. It's a strict inequality. It does not have the equal symbol. Because it does not have the equal symbol, I will graph the line as a shaded line or a dashed line. I would write y equals 2x minus 1. It's not a solid line. If the inequality had the equal symbol, I would have graphed it as a solid line. But right now, I cannot graph it as a solid line. And in step number 3, I pick a point. And you can say, pick a point where? Well, you see that this line divides the entire coordinate system in 2 pieces. The piece below it and the piece above it. And in the piece above it, I have this point that I like the most, which is the origin. But if the line passes to the origin, I have to determine another point. But the line doesn't pass to the origin. So I plug in, so I pick the point, 0, 0, and plug it in. Plug it in the inequality. Y greater than 2x minus 1. Okay, 0, 0. 0 greater than negative 1. Is this true or is it false?
It's true.
It is true. Therefore, I go back and I shade in all the region where that point is coming from. What if it were false? I would have shaded the opposite. But I picked a point in this region. It worked. Then all points will work. All this, the orange region, is this region of y greater than 2x minus 1. Meaning, you can pick any point you want. This, or this, or this, or this, or this. Not this, no. Not this, no. Not any point on the line, of course nothing here. But if you pick anywhere here you want, anything you want, that is the only way we can graph or solve an inequality with 2 variables, a linear inequality with 2 variables. This is the only way. So
if it was false, then you would shade all the points on the other side instead.
Correct. Because if this one if this one creates a false statement, all the other ones will. So I have to go to the opposite. So this is a linear inequality in two variables. Now let's look at an inequality that is not linear. And then we'll look at systems. Okay, 14. Other questions for me, anyone? X squared plus y squared less than or equal to 4. This is no longer a line. I cannot find x and y intercepts. That's not possible here. I have to write the equation first. And question, what is this?
Perfect square.
Careful. Let's dig deep. Back to chapter 2. We had a problem like this on the previous test. And how did we graph it? And what was it? I know you know.
Quadratic?
No? I know you know. Anyone? Okay, here's my hint. That's all I can say, and now I'm on strike.
It's a circle.
Yes, and the radius, and the center.
Radius is 2.
Excellent, and the center.
Is it 1, 1? Or 0? Okay.
Because there is nothing subtracted from x and y. Thank you. So here it is. 1, 2, 1, 2, 1, 2, 1, 2. I got the points. Oh, I'm sorry. I should have asked. I'm sorry. Because we have the equal symbol, I will have to graph it as a solid curve because of the equal symbol. Sorry, I forgot to ask. So then this is x squared plus y squared equals 4. And this time, I see that this curve divides the entire region into two pieces, the inner and the outer. Of course, I will check with the origin because the graph does not pass through the origin. And when I put 0, 0, I get that 0 is less than or equal to 4. If it's true, I will shade in the inside. If it's false, I will shade in the outside. Is it true or is it false?
False.
Oh, 0 is less than or equal to 4, correct? So we plugged in 0, 0, 0, checking
Okay,
with the
yeah,
origin. That's okay. This inside is x squared plus y squared less than or equal to 4. All the inside, including points on the circumference of the circle. So now we have the prep we need to look at systems. I hope you find this somewhat fun at least, please. Okay, so let's look at 46. Same page. And that is y greater than or equal to x squared minus 4. And x minus y greater than or equal to 2. So what's the difference between a single inequality and two? A single inequality will have a solution wherever, but two inequalities, if they don't overlap, there is no solution. Because now we want both inequalities to be fulfilled, both conditions to be fulfilled at the same time. So I start with the first equation, y equals x squared minus 4. How do I graph this? What is it? When x is 0, y is negative 4. When y is 0, then x squared equals 4. So we have x equals plus or minus 2. I know how to graph it. We graph it with transformations millions of times in the past. What is it? What is it? And is it a solid curve?
Yes.
Yes? So what type of graph is it?
Parabola.
Excellent. Thank you very much. Awesome. Great job. Very good. This is the graph of y equals x squared minus 4. Okay, next we have to solve the inequality. Yes, I would pick, because I see this graph divides the entire region into two pieces, the inside and the outside. I'm going to, of course, check the inside with the origin, see what I get. 0, 0. I get that 0 is greater than or equal to negative 4. If this is true, I will shade in the inside. If this is false, I will shade in the outside. Is it true or false? Very good. I may need to extend. So the inside, not the curve, not the function. Everything, all points inside, including points on the function, represent the inequality y greater than or equal to x squared minus 4. I'm done with the first one, completely done with the first one, and now I have the second one. So x minus y equals 2. This is a linear equation. When x is 0, y is negative 2. So 0, negative 2. When y is 0, x is 2. So 2, comma 0. I plot 0, negative 2 right here and 2, comma 0. But I can't graph before I identify whether I have to graph a solid curve or a dashed curve. Solid, excellent. This is just the equation. X minus y equals 2. I have to solve the inequality. I realize that this line divides the territory in below and above. I'm going to check with the origin. I'm checking the above. With the origin, 0, 0. I get that 0 is greater than or equal to 2. Is this true? If you say yes, I'll shade in the above. If you say no, I'll shade in the below.
No.
Very good. So this is false. So I cannot shade in the region that had the point that I used. I have to shade in the opposite. What you see here, including points on the line, represent solutions to the second inequality, x minus y greater than or equal to 2. Now, if the green and the brown do not overlap, the two regions, green and brown, if they don't overlap, the system has no solutions. But do they overlap?
Yes.
Yes, they do. So the solution is this. All points on this piece and everything in between. This is both, representing the solutions to the system. If you want to solve the system, you must pick ordered pairs in here, in the orange territory, including points on this line, including points on the curve. If you pick here, only the first one. If you pick here, only the second one. If you pick here, none. Or here. Only in the orange region.
Can you scoot the paper up a little bit, please?
This way?
Never mind, I thought it said more.
No, it says both. Okay. We have time for one more. Let's take a look, and then next week we have 6.1 and 8.1, and then we'll start reviewing for test 3. Please do not forget, I'm begging you, do not forget to redo test 1 and test 2 every weekend between now and the final. Please, please, please. Okay, so let's look at 50. Same page, and this is x squared plus y squared greater than 1, and x squared plus y squared less than 9. And I could put this book away. Okay, so obviously we had something similar before. What is this? Can anyone tell us?
Circle?
Yes, with the origin being the center and the radius being one. Radius is 1, center 0, 0. Perfect. So do I graph it as a solid curve or not?
Would it be a
Not.
rounded curve?
Very good. It's not. This is just x squared plus y squared equals 1. I check, of course, with the origin, 0, 0. Is 0 greater than 1? If you say yes, I'll shade in the region that I checked with the point. If you say no, then I'll have to shade in the exterior.
No.
No. Excellent. All this is x squared plus y squared greater than 1. I'm done, completely done with the first one. Now I'm looking at the second one. X squared plus y squared equals 9. What is this?
Circle?
Yes, still the origin because there is nothing added or subtracted to y or x. And the radius is?
9.
Right?
Sorry.
No worries, no worries. So, here it is. Solid curve or not?
No.
Very good. This is the x squared plus y squared equals 9. Pick 0, 0 again because it's the inside or the outside. So with 0, 0, I have that 0 is less than 9. If this is true, I will shade in the inside of the green. If it's false, I will shade in the outside of the green.
Yeah.
It's true. The inside green is x squared plus y squared less than 9. Now I have to intersect the red with the green. Do they overlap, red and green?
Yes.
They do. So not points here, not points on the curve, not points on this curve, but everything else. Like a donut. The purple is both.